In this video, we're going to finish the drawings based on the names provided here. So we have some more alkanes to draw. Let's go ahead and take a look at 2-methyl-butane. So let's start with the parent chain first. 1, 2, 3, 4. Number from any direction you want, either here or here. So 1, 2, 2-methyl. Let's then go and do our structural formula here. So 1, 2, 3, 4. You can connect the carbons. Carbon number 2 would have the methyl, so 1, 2 right there, CH3. And then you can make it condensed or expanded, it's up to you. I'll do CH3, CH3, CH2 here, CH3. And over here, I'm going to do, you have to be careful here, because normally in the middle, you would put 2 H's, but you can't in this case here, because look, this carbon already has 1, 2, 3. So this only needs really 1 H to be happy. And that leads me to a mistake I made in the previous video, so hopefully you see it here. This carbon over here, because it has 2 substituents on it, doesn't need any H's at all. It was already happy. So I made a mistake there. So very easy to make a mistake if you're going too quickly. And there it is, corrected. Okay, so be very careful. I didn't catch that because I was going too fast. And then the other mistake I didn't catch because I was going too fast, right here, look at this. That carbon there did not need 2 H's, it just needed 1 H because it already had 1 substituent on it. So if there's no substituents, they need 2 H's to make it happy, 4. If there's 1 substituent, just 1 H. If there's 2, well then no H's at all. So again, another mistake that I caught there. And so if you caught it in the last video, good job on you. If you didn't, hopefully you see it now and it won't make those mistakes going forward. Very easy to make mistakes if you're not paying attention. So now let's go to the next one, 2,4-dimethyl, 5-propyl heptane. So it's a heptane molecule. Let's draw a parent chain first. So 1, 2, 3, 4, 5, 6, 7. And we're going to count from any direction. I'll start counting from the left side. So 1, 2, on carbon number 2, there's a methyl. 3, 4, a methyl on carbon number 4. And then 5, a propyl. 1, 2, 3. So this is 1, 2, 3. It's a propyl there. Now, here's something I want you to notice. Sometimes when I draw from a name, I go back and I rename the drawing to see if I get the same answer. And so if I do that, if I look at my parent chain here, 7 carbons, I notice something interesting. That's actually not my longest chain. There's actually a longer chain over here. 1, 2, 3, 4, 5, 6, 7, 8. That means this name is wrong. That means that name actually doesn't fit this molecule. The wrong parent chain was used. So the better name for this is actually, so we have our 8 carbon group. We're going to start numbering. I think numbering from here would give us the lowest substituent at the first point of difference. There we go. So we would have 5 ethyl, then 2,4-dimethyl, and then octane. And that's the better name for that molecule. So let's go ahead and do the structural diagram for this. Let's do our 8 carbons. That's 1, 2, 3, 4, 5, 6, 7, 8. On carbon number 2, we have a methyl. Carbon number 4, we have a methyl. On carbon number 5, we have an ethyl. So 1, 2, 3, 4, and then 5. They could all be facing down. They could be facing up. Doesn't really matter. CH2, CH3. Now we can go fill in our H's. So H3 here. Here it's just one H because it's already a substituent. Here it would be two H's. Put your line there after. Here we already have a substituent, so just one H. Here we have a substituent, so just one H. Then H2 here because there's no substituents. H2 here. And then at the terminal, H3. And there we have our 5-ethyl, 2,4-dimethyl octane. So now let's go take a look at the next example here with an isopropyl molecule in it. An isopropyl substituent, which is interesting. We haven't done one of those yet. We'll go take a look at what that is. So let's start with drawing our parent chain. So again, 1, 2, 3, 4, 5, 6, 7. Start counting from any direction. It doesn't really matter where. We'll just start counting from left to right for me. You can do from right to left. As long as the substituents are in the same relative spot, we're good. So carbon number 2 has a methyl. Carbon number 5 is a methyl. So 1, 2, 3, 4, 5. Carbon number 3 has an isopropyl. So isopropyl, if we go back up here, isopropyl is actually still 3 that's actually butyl, sorry. Still 3 carbons, but you connect the propyl group to the second carbon in that 3-carbon chain. So in the line diagram form, it kind of looks like this. So it's on carbon number 3. So 1, 2, 3. So that way you have 1, 2, 3 carbons, and it's connected to that middle carbon there. So it's isopropyl. So let's try to do the same thing, but this time for the structural formula. So we'll do our heptane. So 1, 2, 3, 4, 5, 6, 7. On carbon number 2, we have a methyl. On carbon number 5, we have a methyl as well. Carbon number 3, we have a isopropyl. So you get that's CH3, and this is CH3. Notice that the middle carbon only has one H because it already has a bond from the carbon up here, here, and here. And that matches what isopropyl looks like over here. CH, CH3, CH3. And then we can go put in our H's for the other carbons. So if we do expanded completely, that's 3 H's here. 1 H here. 1 H here. That's a single bond here, by the way. 2 H's. 1 H. 2 H's. And the last one here, 1,1-dimethyl, 4-ethyl cyclohexane. So let's start by drawing our cyclohexane parent chain. And we say 1,1-dimethyl, 4-ethyl cyclohexane. So doesn't really matter which one is number 1, just choose any carbon. And we have 2 methyls there. So a methyl here and a methyl here. And then, so that's 1, then 2, 3, 4. So it's carbon number 4 here. So 1, 2. So we have 1,1-dimethyl, 4-ethyl cyclohexane. If you want to draw this out as a expanded or structural formula, on carbon number 1, we have, you can even draw it this way. You could do CH3 like this, CH3 like this. Carbon number 4, you have your CH2, CH3. Then you can add in your H's where needed. So the carbon here needs 2 H's. This one needs 2 H's. This one needs just 1. This one needs 2. This one needs 2. And now we have 4 bonds on each carbon, all the substituents in, and that's how we draw 1,1-dimethyl 4-ethyl cyclohexane. So in this video, we just finished off some practice problems involving drawing. You should know how to do any format for drawing as per the tutorials you've seen here, whether that's condensed structural, or bond line diagram. You should know how to put the correct number of hydrogens. Make sure you count them carefully. As you saw, it's very easy to make mistakes. I made a mistake just because I wasn't paying attention properly here. So you always go back and recount your hydrogens to make sure you have the right amount on them after you've placed them. Be sure you can go from drawing to name as well. And the naming rules are all over here for you. So go over the naming rules again. And really the best way to become better at this is to just practice, make mistakes, and avoid making those mistakes next time. So if you made mistakes while you were practicing on your own, now you have a toolbox of, where those mistakes are, you can avoid them. So there's a tripping hazard somewhere. You're tripped on it once before, now you know not to trip on it again because you've made that mistake and you learn from that mistake.